Hello, this is Mahmoud Mustafa Al Maruf. Welcome to the video demonstration of my project 07 Local Delivery. It is a hyperlocal delivery platform designed specifically for neighborhood level logistics, connecting local shops, customers, and delivery partners. My system is a unified platform consisting of three main modules running entirely from a single Flutter code base: the customer app, the delivery partner app, and the admin web dashboard. Today, I will walk you through a highly detailed demonstration of my user interface, followed by a look at my Firebase database structure, an in-depth dive into my code-based architecture, and finally, the technical challenges I overcame. Let's dive deep into the user interface. I will start from the very beginning, the authentication screen. Here on the login screen, I focus on a clean, minimal design. Users can enter their phone number to receive an OTP. Alternatively, I implemented a robust continue with Google feature for a seamless one-click login. If the system detects a new user, they are redirected to this profile setup screen. Here, the user enters their full name, their delivery address, and phone number. Here's the customer home screen. At the very top, you see a personalized greeting and a location header. Below that, this is my horizontal category scroll bar containing filters like grocery, fish, meat, vegetable, pharmacy, and parcel pickup. When I tap on pharmacy, the vertical list below dynamically updates to show only medical stores. Each shop card displays the shop's name, category, rating, and a beautiful cover image to enhance the visual experience. Clicking on a shop opens its detailed inventory menu. You can see a clean grid or list of products. Each product card clearly shows the item image, exact price in Taka, and a prominent add button. I will now add a few items to the cart. Notice the micro interaction as I hit the plus button to increase the quantity to 3. Uh, the UI updates instantly without any lag. Look at the bottom of the screen. The floating cart button constantly calculates the total number of items and the running total price. Tapping view cart takes me to the checkout screen. I designed this screen to be completely transparent with pricing. You can see the item subtotal, a fixed platform delivery fee, and a grand total. Here, there is an input field for the exact delivery address. Since I have avoided expensive geocoding APIs, the user manually types their address here. I will confirm cash on delivery and hit place order. Instantly, the app transitions to the live order tracking UI. At the top, the status clearly says looking for a rider. Below, it is a full screen interactive map powered by OpenStreetMap, showing the customer's general area. Now let's switch perspective to the rider app. The rider dashboard is designed for high visibility. At the top, there are large statistical cards displaying their total deliveries and total earnings in Taka. Currently, the screen is empty because the rider is offline. I will toggle the Go Online switch at the top. Immediately, the order I just placed as a customer pops up to the rider screen. The order card is packed with essential information: the shop name, the customer's delivery address, and the specific payout the rider will earn for this trip. I will click accept. The UI instantly transforms. The rider now has a pickup button. Once they collect the food, they click this. Finally, when they reach the destination, they hit delivered. I will mark it is as delivered now. Notice how the rider's total earnings on the top the dashboard instantly increase. If I briefly look back at the customer app while the delivery was active in my orders, you would see the UI dynamically updated to show the rider's name, a phone icon allowing the customer to call them directly, and the rider's live marker moving across the map.
Finally, let's explore my admin web dashboard. Because I compiled my Flutter app for the web, it runs natively in Google Chrome. On the left, I have a persistent navigation sidebar. In the dashboard tab, I have my analytics UI. These top cards calculate total sales, total commission earned by the platform, and order counts. Below them is a beautiful dynamic pie chart visualizing my revenue breakdown, comparing pending orders against successfully delivered ones. In the orders tab, I can scroll through a comprehensive history of every single order on the platform. I design colorful status badge here, so at a quick glance the admin can clearly identify which orders are currently pending, which ones are picked up by a rider, and which are completely delivered. Moving to the shops tab, I have my vendor control panel. If a shop violates platform rules, I can simply click the active or inactive toggle switch to instantly suspend their account and hide them from the customer app. Similarly, in the riders tab, the admin can monitor all registered delivery partners. Here I can track exactly how many successful deliveries each rider has completed and their total earnings. Just like shops, I also have a toggle switch here to suspend a rider's ID if needed. Lastly, in the global settings tab, you can see I can adjust the platform's flat commission fee. Now let's look at the backend powering this UI. I chose Cloud Firestore, a NoSQL database, because my app requires high frequency, real-time synchronization across multiple devices. My database is structured around three core collections: users, shops, and orders. Instead of creating multiple tables for different user types, I use a single users collections. I manage access using a role field, and depending on whether this role is customer, a rider, or admin, my Flutter app dynamically routes the user to their specific interface. The shop collection stores all vendor information. Each document contains the shop's name, category, rating, and banner image URL. Finally, the orders collection is the heart of the delivery logic. A single order document stores the customer details, rider assignment, and a nested array of the cart items. Most importantly, it holds the status field pending, picked up, or delivered. When a rider updates this status on their phone, Firestore's stream architecture instantly pushes the update to the both customer app and the admin dashboard. One of my architectural goals was to avoid maintaining three separate apps. I built a unified routing system. Once a user logs in, the app checks their role in Firebase and automatically routes them to either the customer home, rider dashboard, or admin web panel, all from this single code base. Finally, for the admin dashboard, I use Flutter's responsive layout techniques. The code automatically detects if the user is on a mobile phone or a desktop web browser and adjusts the UI dynamically to fit the screen perfectly. Moving to my code base, I maintain a clean and highly modular architecture. Rather than mixing everything together, I strictly separated my UI design, business logic, and database operations. I organized the project using a feature first approach. All UI screens are inside the screen folder. Database communications are handled by the services folder, and the app state is managed inside the providers folder. This makes the code base scalable and easy to maintain. To keep the app fast and responsive, I use the provider state management pattern. For example, when a customer add an item to their cart, only the cart icon updates rather than reloading the entire screen. This ensures the app runs smoothly without lag. Building this full stack system brought several technical challenges. The first one is the high cost of live map tracking APIs. Implementing live tracking typically requires the expensive Google Maps SDK. I engineered a cost-free architecture. I extracted raw GPS coordinates and rendered them using Flutter Map, a completely free OpenStreetMap integration, dropping my API cost to zero. And the second one is UI overflow on the admin dashboard. Initially my web dashboard broke and showed render flex overflow errors on smaller screens. Refactoring my layout using media query permanently solved this issue. To conclude, building 07 local delivery has been an incredible journey from concept to a fully functional platform. It allowed me to transform the theoretical knowledge of software engineering into a practical real world solution. I successfully engineered a highly responsive cross platform UI, integrated secure cloud authentication, managed real time NoSQL database streams, and optimized live GPS tracking without relying on expensive APIs. For the future scope, I plan to introduce an automated vendor onboarding portal and implement an AI-based route optimization algorithm to further reduce delivery times. This concludes the video demonstration of 07 local delivery. Thank you for watching and I hope you found this presentation insightful.